So hello, my name's Dylan Villiers. I'm an engineering student with the City of Launceston. I've just driven a cardboard boat from this side of Waverley Lake right to the other side and back. And as you can see, my clothes are flawless. I do not have a drop on me. So for all the doubters, all the people who came into the room, especially as you can see, the boat is still afloat out there and I'm as dry as can be. Some of the other doubters include yeah, was definitely another day. just generally, there was a vibe around the office that the boat wasn't going to do very well, but as you can see, still floating, still dry.
My name is Joseph, this is Isaac, and this is Dylan. We're three engineering students from the University of Tasmania, and we're taking part in the City of Launceston's Civil Engineering Cadetship program. This is a summer work experience program that allows participants to gain insights into the local government engineering sector, as well as practical experience on the ground. For 10 weeks, we've been learning about infrastructure, hydraulic modelling, project delivery, sustainability, and drawings. But on top of that, we're undertaking arguably our most important task, building a cardboard boat to carry the Mayor and Deputy Mayor safely across Waverley Lake at this year's Soggy Bottom Cardboard Boat Regatta. We've set out to learn everything we possibly can about the art of cardboard boat building. Along the way, we've spoken to experts, tested prototypes, and overcome obstacles. Our goal is to build the best possible cardboard boat within the strict rules of the event. This is our story.
So it's Monday after the full-scale prototype test we did on Friday, and we're very, very happy with the results. The boat performed fantastic. Yeah, above expectations despite a tight deadline and a few manufacturing errors. In both terms of duration on the water, it performed better, and in terms of weight that it could hold, it performed better than we expected. It ended up supporting 3 engineering students, or roughly 250 kilograms. And we didn't actually time how long it was out for, but given the distances, we traveled across a few trips out onto the lake with it, it seems like it spent more than enough time to get the Mayor around his lap.
The rough estimate is about 30 minutes.
30 minutes, yep. That sounds about right.
Yep. Which is way more than required.
Yeah.
So, we're definitely within the window that we want for actual paddle time. Yep. We are actually going to change a couple of things between the prototype and the final build. So we're making it a little bit narrower, just to help with paddling and kind of getting into it. It was a bit large and unwieldy. So we're making it a bit narrower, a bit longer, just so we don't lose the buoyancy. Because if we just make it narrower, we'll lose about 10% of our buoyancy. So we're just going to increase it and try and get some of that back. But apart from that, it's pretty much staying the same. Same structure within. We're going to do a second hull. So there's going to be the outside hull, and then inside we're going to put a second layer of cardboard just directly on top of the other one, just in case there's any imperfections in the outer hull layer.
Well, the reason is at one point we lifted the boat up and we could see the outline of the tubes on the bottom of the hull, meaning that there probably does need to be slightly more reinforcement there to ensure the tubes don't fall through.
But that shouldn't be too much of an issue.
Overall though, very, very, very impressed by the performance. In the end, we didn't really get wet until we leaned back and brought the water. Yeah, we almost purposely. Because one thing is when you're testing a prototype, you usually test a failure. So what you want to find is which part of the design gives out first.
You got to see how it's sunk, and if that's preventable. But it's not, because the way it's sunk was it soaked the cardboard soaked through, which you can't do anything.
Which is
about,
ideal.
so.
Having the cardboard soaked through is the ideal result. That means that it's not giving away to structural failure.
All right, let's go build a boat. also worth noting there's been a substantial increase in optimism here between these four walls following our full-scale prototype test. So
I was always optimistic.
we'd like to thank all of our colleagues for their continued support. They've all been there with us since day one, and so now as we're approaching the end of our construction, it's always nice to know that support has never wavered, so thank you all.
I think doubt is something that has plagued boat builders throughout the ages. Because the ocean is the ultimate test. Will the materials we've used stand up to the job? How much pressure can cardboard really take? Have we made the right design choices? Could we have done things better? Is there a fatal flaw in our design that we haven't recognised? Is our boat crew up to the task? Have we built them a vessel that gives them a good chance at actually winning? At some point, you have to put all these doubts aside and trust in the calculations, and trust the testing, and you have to trust in the crew. So this is our completed boat. She has a length of 2,250 millimeters, a width of 1,170 millimeters, a buoyancy of about 300 kilograms, and a weight of also roughly 30 kilograms.
Okay, let me talk you through some of the features this amazing boat has. It's packed full of features and extras that you won't find in every cardboard boat. So we have a custom, I think the centerpiece really of the whole boat, custom Tassie Tiger on the front. Pretty nice, pretty classy. Up the back we have a custom made flag holder, which is comes with the flag. That's an optional extra, but sprung for the best for the mast. So you know we have that as well. In the middle area, we've gone for the luxury package of cutting out shapes for you to actually sit without cutting your back open, which is just fantastic. Very comfortable, very nice to glide through the water with. We've also got these custom markings as well to tell you where the hell to sit, so you don't put your ankle through the bottom of the boat. Very best cardboard boat money can buy. With the right crew, I think this can be a real winner.
Handing over the completed boat to the Mayor and Deputy Mayor was great. They were really impressed with the boat, and they had a lot of questions about how it was designed and built. After throwing a few potential names around, we decided to name the boat Prudence, which is derived from the City of Launceston's motto, Progress with Prudence. While the Mayor and Deputy Mayor clearly had confidence in the boat, Dylan was eager to get the tick of approval from one more person.
My question to you, Greg, is do you now trust us so much that you would sail this? Would you get in this boat yourself?
I would definitely get in this boat myself after seeing...
On water?
On water, after seeing the first attempt, where actually 3 were in it.
Yep.
I would feel quite comfortable to place myself in this, knowing that I could get across the dam. So
I certainly feel better having your confidence.
My confidence.
Over the past few weeks, we've tested sink models, small-scale prototypes, and then a full-size prototype. As we've learned things along the way, we've incorporated those lessons into the final design of Prudence. But the million-dollar question remains: will the boat float?
Will the boat float? So the first calculation we'll do to determine if it might float is we'll calculate the buoyancy of the boat. Calculating buoyancy is very, very simple. The first thing we do is we just find the area of the boat, or the bottom of the boat, which we know to be 1.6 metres longitudinally and 0.6 metres in width. To get the area, we just multiply these two numbers together, and that will give us roughly 0.96 metres squared. The next is we just multiply this by the depth of the boat, so we'll just times that by roughly about 0.3 metres. That's about how far the boat will go down into the water. This will give us roughly 0.288 metres cubed. Okay, now we know 1 metre cubed is equal to 1,000 litres. Therefore, this here is roughly 288 litres of water. So what does this mean? This means that this boat is capable, when pushed down into the water, of displacing roughly 288 litres of water. The 288 litres corresponds pretty much exactly to 288 kilograms, which means that the buoyancy of this boat is going to be roughly 288 kilograms, as in it will displace 288 kilograms of water. So this calculation isn't perfect. The boat, as you can see here, has these tapered sides, which means that as it pushes down, the area at the bottom, this area here, is actually increasing. So it's like it's bigger up there, right? That means the buoyancy increases as the boat is pushed down into the water. So the buoyancy is actually probably more like about 300 kilograms. So what does this mean? This means that the boat should be able to hold 300 kilograms. So if we overestimate the mayor and the deputy mayor's weight, we say they both weigh 90 kilograms, and 2 times that is just going to be 180 kilograms. Well, that's well under the 300 kilograms the boat can support. Does this mean it's going to float? Well, we're still not sure, and we've still made a lot of assumptions in this. We haven't considered the self-weight of the boat. How much does the boat weigh? We haven't considered, and again, like the tapered edge here, that's a variable that changes over time. As the boat soaks in water, it's going to get heavier and heavier, meaning the self-weight is actually going to increase in time. But let's just say the final boat ends up weighing roughly 50 kilograms. That means our self-weight and the weight of the mayor and the deputy mayor is going to be 230 kilograms. Again, this is still well under the calculated buoyancy, which means technically it should still work, hopefully. But again, there are other assumptions that come back to haunt us, and the main one that we haven't accounted for here is actually the cardboard. All this assumes is that the boat goes down, does not deform, stays rigid as it enters the water. However, in reality, cardboard is probably not going to do that very well. So that's where sort of the structure of the inner hull and the tubes and all that sort of stuff comes into play. All the tabs and gussets and stuff that are placed on the corner. What we're doing with the tubular system and all that there is we're hoping to distribute the load of the passengers evenly throughout the hull, so that all that force that's coming down and pressing down on here, and therefore the water pressing back up here, we're hoping that's as evenly distributed as possible, so that there's no weak points in the bottom of the boat causing a puncture and therefore sinking the boat. So that's what the tubes do. They distribute all the load and they make it so it all behaves as expected. In the end, we cannot say with any certainty whether or not the boat will work. There are simply too many factors to consider. All this really is very, very basic modelling that sort of guides the process and gives us some confidence.
And just like that, our 10 weeks work placement at the City of Launceston was up. We had the opportunity to say our goodbyes at a morning tea, and we wanted to thank everyone who had helped us along the way.
And we also want to do a few quick thanks as well about our Soggy bottom cardboard box boat, because it really has been I think taken the whole office, or the whole organisation's really come together to help us build it. So I think what started out as a bit of a backroom project for the three of us, I think it's actually been quite nice how much everyone's been prepared to be involved, whether positive or not so much at times. So I think these two have got a few personal thank yous.
So first off, I just want to thank everyone in this annex just for putting up with us building a boat in one of the offices. Apparently, we had a comment once that it sounded like we were making a new desk or something with all the soaring and that type of stuff that was going on. So thank you for putting up with that, and thank you for all the guidance and discussion that you helped along the way with. That was very helpful.
Certainly not all the ideas were ours, and some of the ones that were fleshed out by a lot of people who were just curious, and that was really great to have someone to talk to and flesh out the ideas. And also, we definitely have to apologise for that room, because we're not sure if it's ever going to be quite the same. There is a lot of cardboard fibre in that carpet. So hopefully we can figure out how to get that out this afternoon, otherwise it's not really our problem so much anymore. And also, especially thanks to Greg and Lockie, who helped us cart all sorts of cardboard, tubes, all over the place, and also actually get the prototype out to the lake. It was quite big at the end of the build, so thank you very much, and your services might still be needed for the final one to get that out to Waverley Lake. And also Michael Newby for doing a lot of the arrangements of that as well.
Also went to Greg Beeson and all the guys out at the recycling centre. They were absolutely fantastic when we cruised out there and said we want cardboard en masse, and they were happy to set aside a corner for us and keep all sorts of weird and wonderful shapes. So big thanks to those guys.
Yep. Cool.
And good luck. Good luck. I hope it works.
As we wound up our time at the City of Launceston, Prudence was moved into a back room where she would remain safe and sound. Now we just have to wait for race day.